Welcome to Unit 1.7, where we're going to talk about selecting procedures. The first thing we're going to talk about is rationalizing functions with radicals. Rationalizing functions with radicals basically means is when you multiply your radicals using its conjugate. Over here, I put the difference of squares equations, which is a plus b times a minus b equals a squared minus b squared. Now, let's take a look at an example. If I have a limit as x approaches 5 given this f of x, and I'm trying to solve for it, the first thing I'm going to look at is what can I do first. I can't do direct substitution because it would equal a 0 at the bottom, and I can't factor it. So what I have to do, knowing, is that I have to multiply this radical using its conjugate. Going back to this equation, I'm going to identify my a and my b. As you can see here, this top equation, the square root of x plus 4 would be my a, and the minus b, the 3 would be my b. So if I'm going to multiply this by its conjugate, which is a plus b, I would multiply this x plus 4, square root of x plus 4, plus 3. And whatever I do to the top, I have to do to the bottom. So I would also multiply the bottom by x plus 4 plus 3. Now, looking back, if I were to multiply two square roots together, I would get square root squared. As you know, a square root squared will cancel each other out. So when I rewrite this, I will just have only x plus 4. However, I do have to also square the 3. So I would get x plus 4 minus the square root of 3, which is just 9. And then I would just add the rest of my equation at the bottom. And what I'm left with is this. Now, if I can simplify more the top, I would get x minus 5 over x minus 5 times the square root of x plus 4 plus 3. Now that I have my equation here, I can see that I can cancel out my x minus 5s on the top and on the bottom. This leaves me with 1 over the square root of x plus 4 plus 3. So now that I have multiplied my radicals using my conjugate, I have factored and I have canceled out my equation, the last thing I have to do is do direct substitution. So I have 5, and I'll just plug in my 5 into my x. So I'll have 1 over the square root of 5 plus 4 plus 3. Which gives me 1 over the square root of 9, which is 3 plus 3, which ultimately I would get the answer 1 over 6, and that would be my answer. Next thing we're going to talk about is complex functions. Let's do an example. If I had the limit of x approaching 0 of x over 1 over x minus 4 plus 1 over 4, this would be a lot. So the first thing you need to do is break it apart. Let's start with the denominator. Looking at this looks like a regular LCD equation where you have to find the least common denominator. The least common denominator for 1 over x minus 4 plus 1 over 4 would be 4 times x minus 4. So thinking back to pre-cal to algebra, you would have to multiply 4 to this side and x minus 4 to the other side. And remember, what you do to the top, you do to the bottom. So after doing this equation, I know I would get x over 4x minus 4. I would have to multiply 4 times 1. That gives me 4 plus x minus 4. 4 minus 4 equals 0, which leaves me with an x at the top. But don't forget that you had a numerator already, so it would be an x over 4x minus 4. This still is a very complex function, so you want to break it apart again. So if I had x over 1 and I want to multiply it instead, remember, if you multiply a fraction, you flip the numerator and denominator. So I would get x over 1 times 4x minus 4 over x. So this looks way easier to handle. obviously we can see that we can cancel out the x's. So that's what I'm going to do. And we're left off with the limit as x approaches 0 of 4x minus 4. And all we have to do now is direct substitution. So I plug in my 0 for x, and I get 4 times 0 minus 4, which gives me 4 times a negative 4, which ultimately gives me a negative 16. And that would be my answer to this limit. Thank you for watching.